Okay, so let's see how we go about this angle. We said we have three cases that start: the acute angle, the obtuse angle, and then also the right angle triangle. We have seen the the first one. Let us see the second one when the angle is acute. So the forces of 8 newtons and 10 newtons inclined at 60 degrees, that our angle here is acute. Find the magnitude and direction of the resultant force. So what we do first is, we say the moment you see that the angle is acute, you handle this question using parallelogram of forces. So what you do, you first get your forces here. So I'm going to assume these are my forces here. Then my parallelogram, complete my parallelogram, I will use this. Then the other force is going to be here. So it's going to be there. Then to have the parallelogram side, this side there. Then join it like this. Because these are. So these are what we use. So first of all, set the angle between these two forces is 60 degrees. What are the forces? The first one is 8 newtons. So this one is 8 newtons. And then this one is going to be our 10 newtons force. So what happens there? Now see, if I want to get a resultant, the resultant said if this is parallel to this, we say that this one is also going to be 8 newtons. Then we said this one is going to be the 10. There will be actually this force here is 10 newtons. So we say this one is going to be a 10 newtons force. Because it's the same there. This is parallel to this. The force is the same here. Now, if this is 60 degrees, it means that because this is a straight line, the balance here is going to be 120 degrees. Now, the resultant is going to be the force that is going to act there. So the R resultant is going to be this force here. So, this is going to be our resultant force, which we can easily get the magnitude. So we have this side, we have this side, we need this, we have this angle. So there, the basic way to use that is to use that sine rule. The cosine rule. So using that sine rule, how does it state? It says a square will be squared plus c squared minus 2bc cos of the angle A. So if you take this to be A, our force here is going to be now Fr squared is going to be equal to the opposite side, the adjacent sides between this angle. So we have this one, the 10 squared, then plus this one is 8 squared, then minus 2 into 10 into 8, then cos of our angle between these two sides, which is 120 degrees. So now our resultant force is going to be the square root of, this is going to be 100 plus 164, then minus, this is going to be 80 times 2, 160, then cos of 120 degrees. And so, give our force in newtons. So, this is going to be, don't ever do this. Some people do this mistake. Don't say this minus this. No, this is one thing. So what you do is say 160 cos of this, then you say answer, and this minus answer. So don't ever do that mistake, please. So me, I'm getting 15.6205 newtons, and that will be our resultant. The moment that the angle is acute, always the resultant is going to be bigger than the two forces. Okay, now from there, what happens? We come and we get now our direction. So let us call this our, let me call this direction to be our theta. So this is the direction we want. How are we going to use? So let us explore the direction. Then we use the that triangle. Let me pull that triangle out. This triangle, if I pull it out, this is what I'm going to be with. Okay, that's what I'm going to be with. I'm going to pull out that triangle. Now I have this FR. This one is now 15.6205. I have this as 120. I need this theta, but I have this force here is 8 newtons. So now to get this, we can use the sine rule, which says sine theta over equaling to, now this sine 120 degrees over the force 205. And so our theta here will be 8 sine inverse of 8 times this, 8 sine 120, the whole over 15.6205. Then you get your answer. It's going to be 8 sine divided by here I'm getting 26.3. Give 2 decimal places. So that will be the direction. So you can easily describe as it's been seen how we are doing that. What happens if we have this? Now it's like this one, the angle is going to be obtuse. The force is this and this are equal at 120. So we do that. We first draw. This is going to be one force. Then the other is going to be here. Because the angle is obtuse. Is that our angle? There is obtuse. Okay, so the first force here is going to be this. Then you call this 3 Newton's force. And then this one here is going to be the 2 Newton's force. The angle between them is 120 degrees. So if we have that, they're asking us to get the magnitude and then the direction. I think from here, you can see that we're just going to apply that idea. So we use the paragram of forces. So all I'm going to do, I need this. So I'm going to do this thing here. Okay, so what do I have? I need, first of all, I need all this, my alpha. So this is going to be my resultant FR. Okay, if I have this now, you see, I have this, I need this. There we are going to use the cosine rule. So using cosine rule, what does it say? It says now FR squared is going to be this squared plus 2 squared minus 2, 3 into 2, then cos of 120 degrees. And so from here, directly give us our FR. Will take us through the process. So this is going to be 9, that's going to be 13. 13 minus, this is going to be 12. So it's going to be 4.3589 newtons. So our direction is going to be alpha. We say alpha is going to be sine alpha over the force opposite to it, which is 2, will be equal to our resultant, which is using sine rule. Okay, here we are using sine rule. So it's going to be equal to this, which is 4.3589. No, sorry. The angle is not which I'm starting with first. Okay? The angle is sine 120 over the force 4.3589. And so here my alpha, you give the answer direct from there. Don't take out of 2. So the angle I'm getting here is 23.41 degrees. That will be the direction. I think you've seen how to describe it. So when we have the acute angle and then the obtuse angle, so that the idea looks similar on how it is. But this one, whenever they give you obtuse, it's very easy. That when they give you the acute, whenever they give the acute, you always create this triangle, this triangle there, and then you get the answers as you see. Let's remember now we are going to see, we are going to see more tricks about this when they give them to you in vector form.